we're discussing section 14.5, the B and C level problems. The first problem I wanted to draw your attention to is problem number 15. The question is, which of the following properties are invariant under any dilation? Now remember, dilation is a similarity mapping. It's not a congruence mapping. So if you go back to your definition of similarity, the angles are congruent between two similar figures and the sides are in proportion. So what is preserved is not distance, which is answer A, not angle measure is preserved, so answer B is correct. Area is not preserved since it's a similarity mapping, and orientation is preserved. So the answer is that angle measure is preserved under a dilation as well as orientation. Moving on to problem 18, the directions are that you have to graph quadrilateral PQRS, and so here are the coordinates of the points PQRS, and when I graph them, there it is. This is the pre-image. Then what I need to do is I have to apply a dilation and graph its image. Now the dilation given is the dilation centered at the origin with a scale factor of 3. So what I need to do is I need to multiply each of the x and the y coordinates by 3 in order to get the image of the point that's the pre-image. So negative 1 times 3 is negative 3. 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. And so on. You can see where the 12 comes from. And 2 times 3 is 6. 2 times 3 is 6 there. So any point xy under this dilation gets mapped to kx, comma ky, where the scale factor k is 3. All right, now here's my picture. One box is 1 square unit, and I graph the pre-image, which I've already done, and here's the image. So what you can see is that the image has been blown up by a factor of 3. The angle measures are all the same because it's a similarity mapping, not a congruence mapping, but this side, P prime S prime, is 3 times as long as this side, PS. So you can see here really obviously that distance is not preserved. All right, the last couple question is they want you to find the ratio of the perimeters. Since the scale factor is 3 over 1, the ratio of the perimeters, since it's a linear thing, it's going to be the same as the scale factor, so it's 3 to 1. And the ratio of the areas, area is a square kind of thing, so it's 3 squared over 1 squared, so the ratio of the areas is 9 over 1. That's problem 18. Problem number 21, which is the last problem, is very similar to 18, although they give you a different dilation. Okay, this time the dilation is centered at the origin, and it's got the minus sign in front of a half. So we know that this is a contraction. The other one was an expansion. This is a contraction. It's taking all the side lengths and it's making them half as long. But we got this little minus sign here. The minus sign in front of K means that not only is the image contracting, but it's also being rotated 180 degrees, a half turn. So you can see that right here I plotted the points P, Q, R, and S. Okay. Point P here was negative 2, negative 2. Point Q here is the origin, which is also the center of the dilation. Just make note of that. Point R is 4, 0. Point S is 6, negative 2. All right, so now it's time to apply our dilation and see what happens to the point. So I multiply each one of these guys by a half. So negative 2 times negative a half, I just misspoke there. Negative 2 times negative a half is 1. Negative 2 times negative a half is 1. 0 times negative a half, still 0. 0 times negative a half, still 0. 4 times negative a half is negative 2. Got a 0 there. You can see where the minus 3 comes from. You can see where the 1 comes from. Okay, so I plot the image points. These are the image points. So let's look down here and see the image points. All right, so in this case, because point Q, you'll notice, is at the origin, which is the center of the dilation, it doesn't move under dilation. It stays where it is, which that's something we've talked about in class and we all know. So there's point there's Q is equal to Q prime. So the pre-image is actually equal to the image. Now point P here goes to P prime. There's P prime, 1, 1. R prime is negative 2, 0. There's R prime. And S prime is negative 3, 1. So there's S prime right there. All right, so you can see here's my original image, and here is the image under the dilation. So not only has it been squashed, but it's also been rotated a half turn. So you can see, you take this little guy, just like a sprinkler, all right, and there it goes, 180 degrees. All right, that is the end of this one.